My name is Dave Mark. I am the president and lead designer of Intrinsic Algorithm. Started as an independent game company about 10 years ago, but more recently I have been doing AI consulting. I'm also the author of the book Behavioral Mathematics for Game AI, which came out in 2009. And I have written for AI Game Programming Wisdom 4, Game Programming Gems 8, and Game Developer Magazine, as well as numerous blog posts.
You also did this little thing called the AI Game Programmers Guild.
Yes, indeed we have. It started out as a little thing, but we now currently have 250 plus professional AI programmers in the guild. It started about 3 years ago just as a Google group for us to have discussions in kind of a noise-free environment. But then the AI Game Programmers Guild is who then puts on the AI Summit every year at the Game Developers Conference.
Okay. How did you get into doing game AI programming?
You know, I'm not entirely sure, but it's something that, working on some pet projects of my own, I realized that I enjoyed doing. I've always had an interest in things like mathematical modeling of behavior, which is why I decided to write the book that I did a few years ago. But just the more I got into it, the more attractive it became to me. And as a consultant, I eventually found out that people seemed to like what I had to say about it. So that's why I'm doing consulting for other studios.
Are there elements of traditional computer science or mathematics or other fields, psychology, cognitive science, that you draw on regularly?
Absolutely. Especially, people, figure that yes, there's computer science. A lot of, at the very core, a lot of AI is fancy if-then statements. But one of the things that I have always tried to get across to people is that if we are modeling human behavior or animal behavior, it certainly helps to understand, well, how do humans think? How do animals think? And trying to recreate that. And so matter of fact, this year here at the AI Summit, I did a lecture on psychology for AI developers. Not the psychology of AI developers, that would be scary. But, what are things that we need to be aware of in order to model behavior, especially behavior that would be compelling to the player? So there's other things that you can do in there as mathematics, even simple mathematics, economic theory, game theory, decision theory. So it is more than just, okay, I've taken a couple programming courses and I can write, an if-then statement and a while loop. Albeit, that is important, of course. So.
Do you have an example of how game AI has improved a game that you've worked on that you're able to share?
Not a lot of them that I'm able to share as a consultant. Strangely, some companies don't like to admit that they use outside consultants. But I think a lot of the things that I do for companies is break them out of the very rigid mold of this is, the very simple, and yet predictable solution. And so much of what makes game AI compelling is the player having to figure out exactly what's going on. In order, if it's really obvious, then it's not necessarily also not fun, but not AI. If you're playing tic-tac-toe, as a player, your choice is: do I want to lose, or do I want the game to continue? And while that's a choice, it's not necessarily a fun and compelling choice. And so by having AI in a world that is slightly more complex, it gives the player that sense of exploration and interaction that is, using tic-tac-toe as the example, just not there.
So to carry, forward, what would you say is the most important thing that educators need to know about game AI versus academic AI? Where are you seeing questions from students kind of going wrong?
First of all, the definition of terms is the problem of artificial intelligence, especially for those who are experienced with artificial intelligence in academia. We have adopted over time the AI moniker for artificial intelligence, but that's not actually what we do. We do artificial behavior, we do experience management, and so to say, well, AI in the classic academic sense, or in robotics, or things like that, where we're trying to solve this big, huge problem, solve an equation, as it were, doesn't necessarily overlap with what it is that we're trying to do in just creating a compelling and hopefully fun experience for the players. And so that is where a lot of the confusion lies. If you're in a game program, for example, and you have an AI course, they may say, well, here are some of the classic artificial intelligence things such as neural networks and genetic algorithms. And we have very, very little use for any of that. One of the staples that we do, see, being taught, thankfully, is various pathfinding techniques and steering techniques such as A-star, local steering, going back to Craig Reynolds' steering behaviors, etc. But a lot of it, whether the technique is something as simple as finite state machines or into some of the more common use behavior trees, utility-based systems, and even planners, the tool isn't as important as how to think about the problem. What is it that we're trying to enable in our designers to put into the game? And then what is the best tool for the job? And if you can think through that, know the pluses and minuses of what's in your toolbox, so to speak, it doesn't necessarily matter what architecture you use as long as it can support that vision. And I think that a lot of that gets lost in a classroom setting where it's like, okay, you are supposed to learn this technique and then this technique. That's valuable. That is valuable. But on the other hand, you can also teach yourself that kind of stuff. But teaching from experienced people of how to approach the problem and be able to, solve it, as I said, the best tool for the job. That is, I think, where a lot of classroom settings fall down in this regard. So if we can ever figure out a way to teach people how to think, adequately, well, then that we would be much better off. It's a lot harder than it sounds, of course, and some people are cut out for it and some are not. And so that's something, as a student, that a decision would have to be made. Can I think procedurally? Can I think in ways that to wrap my head around, larger behavioral problems and then pick accordingly from the tools that have been offered to me? Some people are naturals at that and fall into it, and others, might struggle. At that point, AI might not be for them. So.
I guess one last thing, if there's anything else you'd like to mention, things you would be looking for in student portfolios, or what you would like to see in the future of AI from the academia.
This is a hard question that comes up a lot from students of, if I am an AI person, how do I get an AI job in the industry? First of all, caveat, you're probably not going to go straight from being a student into an AI job. Be prepared to enter through other ways, whether it be QA or just as a general programmer or even as a designer. A lot of designers end up going. But if you are trying to submit an AI-based portfolio to show what you've done, it needs to work. It needs to show to be compelling. Give a specific thing that this is something that I made that does the standards of its navigating and its deciding and everything. And then if you've done something special, make sure that that's obvious. It doesn't need to be big and flashy. You don't need to have huge scenic stuff. It can be programmer art, as long as you're showing that that it's doing something. But then also be prepared to show your code that you can do changes to your stuff on request. That your code is readable and concise. But the most important thing, and I keep going back to this, is have something that works and that is compelling. You can't just say, yeah, I know how to write an A-star pathfinding routine. Show it. If it's not hard to do a demo that shows that you can do multi-unit pathfinding in a maze type environment, a complex environment. Do that. Not only is it something as a deliverable for prospective employers and interviews, but we can never get enough practice at trying to do these things and improve on them.
Thank you very much, Dave.